Hello everyone, welcome to our St. Joseph's Composite PU College, Vijayapura. I am Azra Suman Madrasi from Department of Mathematics. Today, in this session, we will learn the chapter called Coordinate Geometry. Okay, already we've seen the basic concepts related to coordinate geometry. In this session, we will see the topics which are related to 10th class. Okay, so the topics are distance formula, section formula and area of triangle. So the basics, what we already learned is the distance of a point from the y-axis is called its x-coordinate or abscissa, and the distance of a point from the x-axis is called its y-coordinate or ordinate, and the coordinates of a point on the x-axis are of the form x comma 0 and of a point on the y-axis are of the form 0 comma 1. Okay, so these are the basics: abscissa, ordinate, and the points on the x-axis and points on the y-axis. Already we learned and also we solved some problems related to it. Now let's derive the distance formula, which is very important for class 11. So distance formula, let us now find the distance between any two points P x1 y1 and Q x2 y2. So the green line where the endpoints P and Q having the coordinates x1 y1 and x2 y2 respectively. Now draw the line PR and QS perpendicular to x-axis. This PR and QS are the lines which are perpendicular to x-axis. And now draw the line PT, okay, which is perpendicular to QS. So here you see, when you taking the point P x1 y1, its x coordinate will be x1 and y coordinate will be y1. So the distance OR, this distance OR will be x1 and this distance OS, because our Q point having the x coordinate as x2, so therefore its distance along x-axis will be x2. So the OS will be x2 and OR will be x1. And here the perpendicular distance, that will be your y coordinates. So this distance PR will be y1, and same way because it is a square. Okay, so this ST or TS, both are having the same distance. This PR and TS, that is y1, and also this QS will be y2. Then PT is equals to this distance PT is what? This distance is x2 and this distance is x1, and I want the distance PT, then it becomes x2 minus x1. And QT, I want this distance QT, and already I know QS and TS distance. So how to find this QT distance? That is y2 minus y1. And also already we know the Pythagoras theorem applying to right angle triangle, this PQT, that is PQ square is equals to PT square plus TQ square. Okay, so PQ square is equals to PT square plus QT square. So PT distance is already we know, that is x2 minus x1 whole square plus y2 minus y1 whole square. So this implies PQ is equals to root of x2 minus x1 whole square plus y2 minus y1 whole square, which is the which is called the distance formula. Understood? So this is very important formula which is called the distance formula, using which we will find the distance between any 2 points. Now let's derive this section formula here. Okay. So consider any 2 points A x1 y1 and B x2 y2 and assume that Pxy, this point Pxy divides the line AB internally in the ratio of m1 is to m2. Okay. So this point P, which divide this line, green line AB, into 2 parts, okay, with the ratio of m1 is to n2. Therefore, this PA divided by PB will be m1 by m2. Now draw the line AR, PS and BT perpendicular to x-axis, and also this line PC parallel to these lines. Then by the AA similarity criteria, that is, in 2 triangles, if 2 pairs of corresponding angles are congruent, then the triangles are similar. The triangle APC and BPQ both are similar triangles from the AA criteria. Okay, from the AA similarity criteria. Therefore, the ratio of the respective sides are also equal. So see here, the side AP by BP is equals to BQ by PC, which is equals to PQ by AC. Okay, give it as equation 1, which is written here. Give it as equation 1. Now AC is equals to RS and RS is equals to OS minus OR. You know, OS distance is X and OR distance is X1. So it becomes X minus of X1. And PQ is equals to ST and ST is equals to OT minus OS. Distance OT is X2 and distance OS will be X. So therefore PQ is equals to X2 minus X. Next, PC. Okay, PC is equals to PS minus CS, this distance. PC is equals to this distance I want. PC is equals to whole distance PS minus of CS. It gives you distance PC. So PS is equals to PS only. CS is equals to this distance, CS is equals to AR. So PS is Y and AR will be Y1. So it becomes Y minus of Y1. PC is equals to Y minus of Y1. And last, that is distance BQ. Distance BQ is equals to distance BT minus QT. Okay, and QT, which is equals to distance PS, and BT is Y2. This distance of BT will be Y2 and distance of PS will be Y. So it becomes Y2 minus Y. So distance BQ is equals to Y2 minus Y. Substituting these values in equation 1, we get M1 by M2, because this AP by BP is M1 is to M2 is there. So it becomes M1 by M2 is equals to X minus of X1 divided by X2 minus X is equals to Y minus of Y1 divided by Y2 minus Y. I will consider the 2 pairs, that is M1 by M2 is equals to X minus X1 by X2 minus X for X coordinate, and next one pair, that is M1 by M2 is equals to Y minus Y1 divided by Y2 minus Y for Y coordinate. Okay. Now for the x coordinate, taking the first pair, that is m1 by m2 is equals to x minus of x1 whole divided by x2 minus x. Now cross multiply this x2 minus x2 left side and this m2 to right side. We will get m1 into x2 minus x is equals to m2 into x minus of x1, and multiply this m1 to both these terms. Then we get m1 x2 minus m1 x is equals to m2 x minus of m2 x1. Okay, here you know how to open the bracket. Multiply this term to both these terms and take this m2 x1, which is here minus. When it comes to left side it becomes plus. So and keep this m1 x2 as it is and take this m2 x1 to this side. It becomes m1 x2 plus m2 x1, which is equals to, and keep this m2 x as it is here and take this minus m1 x2 right side. It becomes plus m1 x, and taking x from both the common, that is from the both these terms, we will get x into m2 plus m1, and therefore take this term m2 plus m1, which is here multiplication product. When it comes to the left side it becomes denominator. Okay, so it becomes x is equals to, you will get m1 x2 plus m2 x1 whole divided by m1 plus m2, or you can write m2 plus m1. Okay, so this is the x coordinate. Now for y coordinate, taking the pair as m1 by m2 is equals to y minus of y1 whole divided by y2 minus y. And now here same simplification, cross multiply this y2 minus y to left side and this m2 to right side. We get m1 y2 minus y is equals to m2 into y minus y1, and multiply this m1 to both these terms, that is opening the bracket. So we will get m1 y2 minus m1 y. Similarly this one, multiply this m2 to both these terms, we get m2 y minus m2 y1, and take this m2 y1 to the left side. It becomes, here it is minus, when it comes to left side it becomes plus, and keep this m1 y2 as it is. So that is we get m1 y2 plus m2 y1, and keep this m2 y here as it is and take this minus m1 y to right side, that is minus m1 y. When it comes to the right side it becomes plus m1 y, and take the common y from these both these terms. Then we get y into m2 plus m1, and here m1 plus m2, that is m2 plus m1, which is here in product, and I want the y is equals to, and when you are sending this m1 plus m2 to left side it comes to the denominator. So we get y is equals to m1 y2 plus m2 y1 whole divided by m2 plus m1, which is the y coordinate. So the coordinates of the point pxy, which divides the line segment joining the points ax1 y1 and bx2 y2 internally in the ratio of m1 is to m2 are m1 x2 plus m2 x1 whole divided by m2 plus m1, comma m1 y2 plus m2 y1 whole divided by m2 plus m1. So this is known as the section formula. Our next topic will be midpoint. Okay, so the midpoint of a line segment divides the line segment in the ratio of 1:1. Generally the midpoint means a point which divides the line into two equal parts. Okay, so therefore the coordinates of the midpoint P of the joining the points ax1 y1 and bx2 y2 is, here we are using the section formula as it is, but here the ratio is 1:1. That is, in place of m is 1 and in place of n is 1. So we get 1 into x2 plus 1 into x1 whole divided by 1 plus 1, and 1 into y2 plus 1 into y1 whole divided by 1 plus 1, which is equals to x1 plus x2 or x2 plus x1 whole divided by 2, comma y2 plus y1 whole divided by 2. So this is the midpoint formula. Now let us derive the area of triangle. Let ABC be any triangle whose vertices are ax1 y1, bx2 y2 and cx3 y3 here. And draw the line AP, BQ and CR from the points A, B, C respectively to the perpendicular x-axis. Clearly here, this portion A, B, Q, P, A, P, R, C and B, Q, R, C are all trapezium. Now from the figure, the distance QP is x2 minus x1 because the distance OQ is x2 and distance OP is x1. I want this distance, only PQ or QP I want. So it becomes what? x2 minus x1. Next, distance PR here, and we know the distance OR will be x3 and distance OP will be x1, and I want this distance PR. Okay, it becomes what? x3 minus x1. And QR, we know OR will be x3 and OQ will be x2. So it becomes what? This distance QR will be x3 minus x2. And also we know that the area of trapezium. The area of trapezium formula is 1 upon 2 sum of parallel lines into distance between them. Here we have 3 trapeziums. So that is area of trapezium A, B, Q, P is one trapezium. Next, B, Q, R, C is one more trapezium. And next, last one is area of trapezium, that is A, P, R, C. Okay. And now I want the area under this green lines. Okay. I want this area. Then how to find this area? Area of trapezium this plus area of trapezium this minus area of trapezium ACRP or the area of trapezium APRC. Okay. So because I want the upper portion, upper this triangle I want, the area of this triangle. Adding these two trapezium area and subtracting this trapezium area. Then we will get the area of triangle. So the area of triangle is equals to area of trapezium ABQP plus area of trapezium BQRC minus area of trapezium APRC. We also know that area of trapezium is equals to 1 upon 2 sum of parallel sides into distance between them. Therefore, area of triangle ABC is equals to 1 upon 2 BQ plus AP into QP plus 1 upon 2 BQ plus CR into QR minus 1 upon 2 AP plus CR into PR, where this trapezium ABQP having the parallel sides as BQAP and distance between them as QP. And in this trapezium BQRC, we have the parallel sides as BQCR and distance between them as QR. And in APCR trapezium, we have the parallel sides as AP and CR and distance between them as PR. and BQ is equals to Y2, AP is equals to Y1 substituted, and QP is X2 minus X1 plus 1 upon 2, BQ is Y2, CR is Y3 and QR will be X3 minus X2 minus 1 upon 2, AP is Y1, CR is Y3 and PR will be X3 minus X1. And now opening the brackets, multiply this Y2 to this and to this. It becomes Y2 X2 minus Y2 X1 plus as it is Y1 X2 minus Y1 X1 plus 1 upon 2 because it is taken common, 1 upon 2, 1 upon 2, 1 upon 2. Okay. So plus as it is Y2 multiplied to these both terms, it becomes Y2 X3 minus Y2 X2 plus multiply this Y3 to both these terms, it becomes Y3 X3 minus Y3 X2 minus Y1 X3 minus Y1 X1 plus Y3 X3 minus Y3 X1. Here Y2 X2 both are having the opposite signs, so it becomes get cancel here. Next Y1 X1, here it is minus and here it becomes plus, that is minus minus become plus, so minus Y1 X1 and plus Y1 X1 get cancelled. And last Y3 X3, here it is positive and here it is negative because minus into plus is minus, so opposite signs, so Y3 X3, Y3 X3 get cancelled. Then we get 1 upon 2, so I will take X1 common from this term and from this term. Okay, so that is here minus minus become plus, so it become Y3 plus Y3 minus Y2, so it is written in the next step. And next I will take common X2 from this term and from this term. Okay, so it becomes what? Y1 minus Y3, so it is written in the next step, X2 into Y1 minus Y3. Last one, that is I will take common X3 from this term and from this term, so it becomes what? Y2 minus Y1. So our area of the triangle ABC is equals to 1 upon 2 X1 into Y3 minus Y2 plus X2 into Y1 minus Y3 plus X3 into Y2 minus Y1. Thank you.